Hello everyone and welcome to another MoTeC M1 training webinar. My name is Mark McCoy and I will be your host. Today's the fifth in my series of initial setup workbooks for the M1 ECUs, and today's specific subject will be the ignition configuration. So as usual, if I move over to my M1 ECU, which I have connected on the bench here with me, I'm in my initial setup workbook and I'm on worksheet number 7, the ignition configuration. We'll start over here with the configuration of a few things, and just one thing to note is a few of these numbers or parameters are actually repeated from other worksheets, so don't get too worried that they're a different thing. It just means if you go straight to the ignition configuration, it's sort of almost reminding you what you've got so far so you can maybe review. But yeah, some of these numbers will actually appear on more than one page. So the first one, nice and simple, how many cylinders. The next lot I have here, 1 to 8, which bank are these cylinders on? My example is a 4-cylinder inline engine, so everything is just set to bank 1. There's up to 8 cylinders in this ECU, but if you had one of the larger ECUs it could be up to 12. So I've just got everything set by default to bank 1. A couple of parameters here which should be noted are the ignition timing limit advance and retard. Now in this ECU, because there's many different functions which control timing over and above the main ignition maps and the compensations, what we've done here is we've more or less given you the opportunity to clip those maximum advance and retard numbers, so you know can never go outside a certain bound. Sometimes if you have more than one function working at the same time, the ignition trims can compound and then suddenly you can end up with a lot more ignition advance or retard than you actually thought. So this is a way of limiting the compounding effect of some of the functions. The next two parameters I have here are the ignition charge limit maximum and minimum. Now what these are is, obviously there's a lot going on in an engine especially when it's accelerating fast or decelerating fast. Now what the ECU does is at some point it obviously has to make a decision to start dwelling the ignition coil. The ignition coil, or the testing we do for the ignition coil, sets how long that should be charged for. Now if the ECU has started to dwell a coil and the RPM changes rapidly, you can imagine that the time when it needs to fire the ignition either comes up a bit earlier than expected or a bit later than expected, depending on whether it's accelerating or decelerating. This ECU is smart enough to know that it can adjust the dwell even in the middle of a dwell period. So what we're trying to do is we're trying to make sure that the ignition firing event or the ignition timing is as accurate as possible, even when the engine is accelerating and decelerating rapidly. So it's probably an idea just to leave these two numbers as the default of -50 and +50. It basically just says that if you need to, the ECU can shorten the dwell by a maximum of 50%, or it can extend the dwell by a maximum of 50%. If we're doing a dwell characterization of a coil, we usually do it to a point where it's got full charge, but there's still plenty of safety in it. You don't want to go too far because you could end up burning out the coil, but we can do the characterizations of any coils that need to be done. We've also got a bank of a lot of them we've done in the past. Next on the list is that actual dwell table. So this just simply sets how many milliseconds is the correct dwell time for an ignition coil at different battery voltages. So obviously as battery voltage goes down, the coil takes longer to charge. So we actually characterize that for the customers, and you can then enter that in as a dwell table or a charge time table. Ignition driver delay. This is simply setting a characteristic of the physical ignition parts. You can possibly imagine that the ECU works extremely fast, and you can it can request a spark from a coil, but in reality that coil takes a little while to build up a charge and actually fire the spark out of the spark plug. 40 microseconds is probably a fairly typical value for this number. I wouldn't suggest that most people will really investigate what's correct, but as long as the number is about 40 milliseconds, you really don't need to change it that much. So it's not something that's going to stop your tuning or hinder your tuning at all. So it's just an added refinement, as we tend to do at MoTeC. Ignition driver spark duration. What we have here is more or less a parameter to ensure that there is some time delay between the firings of each spark, or that more or less a bit of breathing space for the coil between dwell periods. Some ignition coils can take a really long time to dwell, like maybe up to 6 or 8 milliseconds. Now you can imagine if you used a coil like that on an engine that revved say past 10,000 RPM, at some point you're going to simply run out of time to dwell that coil completely, and you don't want two dwell periods running into each other. So what we're basically saying here is you have to have the coil off for at least 1 millisecond between firings. So what this can do at higher RPMs, this can actually reduce the amount of dwell time available, because we simply want to give the coil a bit of a break. Now if you're running into this all the time, and you've got an engine that revs a lot further than it did in factory, you may need to investigate putting a coil with a smaller dwell time. Most modern coils these days have a really short dwell time anyway, so you're probably not in too much danger. Some of the older style bigger motorsport coils can sometimes have a really long dwell period, so you might have to be a bit careful in your coil choice compared to the amount of engine RPM you ultimately want to go to. The next two are for multi-spark. Now generally speaking, you don't see too much call for this these days, but effectively what we're saying here is if we're going to fire some extra sparks, we're basically saying over what angle do we want to limit those. So maybe that's 10 or so degrees, and we also want to limit the amount of ignition charge. So basically what we're saying here is we've done our main ignition charge time, or our main dwell, fired a spark, the coil's been off for 1 millisecond, and then we can recharge it with perhaps something like 20% of the original dwell time. The idea here is that the coil won't have fully discharged before we want to recharge it. This is highly dependent on the actual coil you are using, and I would suggest if you really want to have multi-strike ignition, that you really need to contact us about properly testing your coil to give you some numbers to suit the restrike angle and the restrike charge. Moving on to our next calibration element here, we have an ignition driver current. That realistically should just stay at 20 milliamps. This is more or less giving a limit to the ignition outputs on the ECU as to how much current should be used to trigger the ignition module in the ignition system. So 20 milliamps is probably the way to go. Just leave it like that, unless your particular coil has been tested and maybe we have a higher or lower value. Over to our resource calibration element here. I'm just going to turn off the live channels for a second here. All we simply have here is of the number of coils we've got, what are they connected to? So we're more or less assigning a ignition output on the ECU to a specific cylinder here. As I said in an earlier engine details webinar, what we'd probably prefer you to do is set up your cylinders as 1, 2, 3, 4, the same as they are numbered on your engine, and then what we do is we actually connect them to a specific ignition output. Now the example I have here is my engine, which is actually wasted spark. So for 4 cylinders it only has 2 coils, and so what I've done is I've more or less just said to the ECU that 2 pairs of cylinders actually use the same ignition resource. Now if you're not really sure which ones you have to connect to which, I'll just show you a little trick I got shown many years ago by one of our dealers, in that if you need to work out which cylinders use the same resource, for a 4-cylinder you can simply draw a cross, and then in a clockwise manner simply write the firing order of that engine, and anything joined with a straight line needs to have the same cylinder resource. If this is an 8-cylinder engine, I would simply have a couple more lines here, but still the same thing. I would have my firing order of the engine drawn in a clockwise manner. Which ones are joined by a straight line? They're the ones that need to be configured to have the same output. So you can see here cylinders 1 and 4 have the same output, and cylinders 2 and 3 have the same output. Now if this is a sequential engine, I would simply number these exactly the same as my cylinders, so then I would have my 1, 2, 3, 4 outputs assigned to the right cylinder. Now if it's a distributed engine, we're only going to use one output, so I basically simply say to the ECU, okay, all of my cylinders are using the same output resource. So that means that low side ignition output 1 will be firing 4 times for the 4 cylinders, but it's still the one physical output. Okay, and in this example I'm not using the other 8. Again, if you had say an M150 or an M190, there will be up to 12 ignition outputs. So I'll just simply put this back to my waste spark configuration. The last one is simply whether we are using the rising edge or the falling edge as our firing point. This is specific to the ignition module. It's the same as it's always been for all of our previous ECUs. You really need to understand exactly what the electronical makeup of the ignition module is. This parameter here, you have to have it set correctly. If you set it the wrong way, it can result in the ignition system burning out. So be very careful of that one. You need to have that set up correctly. So a simple phone call to us, or simply send in the ignition coil and module setup, and we can test it and tell you what it needs to be. Just going to turn back on my live channels. Just a couple of things I want you to see here. We can see here that we have an output diagnostic for 1 and 3 is okay, and also we're saying for 2 and 4 they are shared. So that's basically getting back to the wasted spark system. The other diagnostics are not in use. I have here, because the engine is off, the ignition output diagnostic is telling me that it's not using the ignition system at the moment, so that should be off. Now if the engine's not running, that's exactly what you'd expect. Also we have an ignition state up here of enabled, which as long as all your setup is correct, it should always be enabled. Just as a bit of an example, just to give you an idea of how smart the ECU is, if we accidentally set up these assignments or resource assignments incorrectly, and now what I'm going to do is I need to actually reset the ECU for it to take notice of that change. Reset. Okay, what it's going to say is it's smart enough to know, based on my number of cylinders and the top dead centers I put in previously, that the ignition setup that I've got here simply can't work. So it's going to tell me I've got a resource error. So it will also, if you've got any kind of configuration error, it will let you know that as a system is just not going to work. So the diagnostics are nice and easy to follow in this case. So I'll just put that back to the way it should be, and we're back to current off, so the system is correctly configured. Lastly, we have a calibration element here, which is more or less for once we have our ignition system completely configured, we've got our ref and sync and all our sensors configured. Same as again with all our other ECUs, we want to be able to wind this engine over and test that our ignition system is set up correctly, and more importantly that our engine speed reference offset is correct. So this is in the previous ECUs, this was called the CRIP, or the crank index position. So what we would simply do is, my advice would be to disconnect the injectors so that there's no chance of any fuel going into the engine while we're doing this test. We're going to set our ignition timing mode to timing check. Now, depending on the top dead center marks you have on your engine, maybe you want to set the timing check to be 0 degrees or maybe 10 degrees before top dead center, whatever your engine has and whatever you're comfortable with. At this point, you would simply wind the engine over. You would use a timing light just to ensure that if we are asking for 0 degrees before top dead center, then that's what the timing light shows. So it more or less is a way of dialing in our engine speed reference offset to be correct with the mechanical makeup of the engine. So it's quite important, but again, the same as we've always done. Okay, thank you for watching my current webinar. Again, all of these will be posted up on the MoTeC.com website and also YouTube. And again, if you have the need to ask any after hours questions, you're more than welcome to join our MoTeC forum at MoTeC.com. Again, thank you for listening, and I hope you can join me for my next webinar.